Hello and welcome everyone. In this video, we will look at an extension of the Gauss elimination method, which is called the Gauss-Jordan elimination method. In this, when we transform the augmented matrix through elementary row operations, the final form produces an identity matrix instead of an upper triangular matrix. This means that we don't need to do the back substitution step as the vector D is the solution vector. We still have the same forward elimination step as in the Gauss elimination method, where we transform the augmented matrix to its row echelon form. However, instead of backward substitution, we now have a backward elimination phase, in which we use row operations to transform the row echelon form to a reduced row echelon form ID. In this case, the elements of D vector represents the solution vector. Let's see how we can implement this method in Python. We write a Gauss-Jordan elimination function. It takes the coefficient matrix and the output vector as inputs. In the function, we run the forward and backward elimination steps and return the matrix A, vector B, and the solution vector X. The forward elimination method is the same as described in the Gauss elimination video. Here we only wrote it inside a function for repeated use. If you haven't seen the Gauss elimination video, I'll place the link in the description. Please watch that for details on how forward elimination works. In the backward elimination, we start with the last row and convert the diagonal element to 1, and then convert all other elements in the same column containing the diagonal to zeros. We then move to the row above and repeat the same process for all rows. After this loop, the matrix A becomes an identity matrix and B represents the solution vector. Let's see how we can solve this curve fitting problem using the Gauss-Jordan elimination method. The entire code remains the same as in the last video where we import Gauss elimination function from utils. Here we import Gauss-Jordan elimination function instead and use it on line 24. The solution is again the same, which is A is equal to 3, B is equal to -2, and C is equal to 4 for the quadratic function. And we get the same graph of this function passing through the three given points. In the next video, we will discuss LU decomposition method. Thanks for watching. I hope you liked this video. Please subscribe and see you in the next video.